All right. So, yeah. So let's start with a discussion of the nested if statement. And the nested if statement is fairly simple. It is where if we have an if statement, right. So if we have if and we have some condition is equal to true, what we might want to do is that we might want to further validate an instruction before we can actually do an instruction. And a nested if allows us to do this. So this here is like the first condition. And then inside of the if statement, we would have if condition 2 is equal to true, then we do an instruction. And we could even have an else one else if. I'll just use an else in this instance to do so what do we have here? Okay, we have if condition 1 is equal to true, when we get inside of the loop, when we get inside of the loop, inside of the statement, we further refine. So if condition 2 is equal to true, else do instruction 1. Otherwise, we want to do instruction 2. So what must be true for instruction 1 to be true? Anybody? Condition 1 and condition 2. If it is that condition 1 is true and condition 2 is false, what will be executed? Instruction 2. If condition 1 is false and condition 2 is true, what is going to get executed? If condition 1 is false and condition 2 is true, what will be executed? Nothing. Because we can't verify condition 2 until condition 1 is condition 1 is true. So in the event that condition 1 is not true, we are in a situation where if condition 1 is not true, then we don't even bother to check condition 2. You all understand where this goes? All right. All right, so let's take a look at and see if we can find an exercise that is going to allow us to test what we have learned here. Okay. My favorite exercise to do this is actually we starting big, right? But we'll break it down into the parts and check it out. So we want to write an algorithm that allows a user to enter a date in the format day, month, year. These values would be stored to 3 separate variables. The algorithm should state if the, and year actually the 4-digit year. The algorithm should state if the, what you call it, allows, if the date entered is valid. So this is something that we want to work through. Something that we want to work through. And we know here, we see here that it seems simple enough, right? Yeah? No? Yes? Might be, mightn't be. Seeing some issues already. All right. We know that a date validation is a big thing that has always been an ache in the backside of programmers ever since, right? And, you know, there's a joke that goes around that it's only going to get worse when, you know, we decide to colonize other planets and stuff like that. Because then you'll have to study not just time zones, but planet zones and stuff like that. Or if you're always using Central Earth time as the core of the universe, but then the colonies might rise up and don't like that. And, you know, those little things could form revolutions. Yes, all that's the time. Okay, so let's say, friends, I'm going to put a date on the board. We have the 19th of the 12th, 1927. Is that a valid date? Yes. Why you all pause? Huh? The month is the 12th, the year is 1927. Right? So the 19th of the 12th, 1927. So validate. Then we have, let's say we have the 31st of the 4th, 2002. Yeah, no? No? Why? Right, so we know that by looking at the month. Did anybody get caught? Yeah. Oh my gosh. Right. April only has 30 days. We know the rhyme, right? Right. It's what? 30 days are September, April, June, and November. Right. Which has 28 days clear and 29 in a leap year. And that's where one of my issues was because all these times I'm going to do that leap year. That's great because this is exactly where we're going. Leap years have rules. Alright? Leap years have more rules than we know, actually. So this is not a valid date. How about the 28th of the 2nd, 2000? Yeah. The 29th of the 2nd, 2000. Yes. We're moving on. So we're taking a look at leap years, right? It was. I'm going to give you all the rules, right? But we're running through. What about the 29th of the 2nd, 1900? No, yes.
I say yeah. I say yeah.
Yes, no.
I say yeah.
Why no, Dalrymple? Dalrymple was the same one who I was talking about his math skills right before class, right? Yes. But the thing is that this is not a valid leap year. Dalrymple is right. Not for the reason he thinks he is, but alright, well he is right. This is not a leap year. Okay? But then the 29th of the 2nd, 1600. Is that a leap year? Yes, it is. Leap years, it doesn't matter when you're born or when you're not born. Leap years have some rules. Okay? And we're going to see it, and this is the thing, that we have to work out the rules, and we are creating an algorithm that is going to follow the rules and validate a date for us. Okay, yeah. 2000 was a leap year. It's not a leap year.
400 years.
Yes. So you already check out the rule. You see, that is the kind of good programmer thinking. You're looking for the pattern. Okay? So we know some things. We just established some things among ourselves here. We've established that some months have different amounts of days. Okay? So if it is that we say month, alright, the months with the 4th month, the 11th month, the 6th month, and the September, the 9th month. Those months have 30 days. We know that for the month, every other month, being, January, March, May, July, August, October, and December. December. Okay, these have 31 days. And then for the month of February, we have some special cases. We have leap year is 29 days. We have non-leap year 28 days. So that should lead our logic into thinking about, well, when is a leap year and when is not a leap year? What makes a leap year and what is not a leap year? So we have to now think about the leap year rules. Okay? We have to think about the leap year rules. And the leap year rules is that a leap year, and we have to express these things as statements, Okay? So again, remember, one of the earliest things I told you all is that everything that we do falls on everything that we previously did. So don't just think about the if statements when doing this. Think about the operators that would allow us to turn what we're about to say here and what I just said up there into mathematical statements. Because what I'm about to do is I'm about to explain it to you and then leave you all to beat up for about 20 minutes attempting it. Okay? Alright? So we have some rules with the leap year. And the leap years happen in any non-century year that is divisible by 4. So if the year is a non-century year, divisible by 4. So what does that mean? That means, example, right, 1996 was a leap year. Okay? I believe 1996 is divisible by 4 without leaving a remainder. Yes? Right? Yes, 4 years before 2000. Okay? Leap years are also century years divisible by 400. So, for example, as we identified before, the year 1600 or the year 2000. These are leap years. So a non-leap century year would be like 1900 as we saw before. Okay? And that is because if you divide 1900 by 400, you get a remainder of 300. And we have those key words, remainder. What do you think about when we hear remainder? Once you hear start talking about remainder, you know that we have to form an expression using a particular operator. Mod. Mod will allow us to figure out what are leap years and what are not leap years. Make sense? Because if it is that we have to know leap years by the remainders that they leave, whether it's a non-century year or whether it's a century year, we have a bunch of things to do. First off, we have to say if a year is, or we have to figure out if a year is a century year or if a year is not a century year. Okay? And once we figure out whether a year is a century year or not a century year, then we could go further and figure out whether it's a leap year or not. Make sense? So, going back up to the top, we know that we have a various amount of days for the month. If I enter a date, again, just to go back to previously entering a date, and I enter, again, let me see, 35/11/1992. Is this a valid date? No, you can tell right off the bat by this. So there are three things we have to learn. We have to validate the day. What is our validation for the day? Right, you can't really pass 31, and our validation for the day has to tie into our validation for the months. So you have to ensure that your months is really the, because I could put the 18th of the, so this is wrong, the 18th of the 14th, right, 1791. There is no 14th month either. So again, this is wrong. So you have to start off, what is our starting point for looking at validation? The month. Because we know for a fact that that month has to fall between 1 and 12 inclusive. Agreed? So you all feel you all have enough to attend this? Or you all feel you all need a little more from me? Alright. What I'm going to ask you to do is I'm going to ask you to attempt it. It does not have to be a pseudocode algorithm or a flowchart. You could write it out as narrative. How are you going to, armed with the knowledge that we have here, how are you going to verify that a date given is a valid date? Okay, we kind of just talked it through, eh? We did the narrative. I didn't really do it in order. But we established that the best place to start is to check the month. In your mind, once we have the month checked, then the next best thing to check would be the day. Except in the case of February, because February have a case where that day is tied to the leap year. Okay? But I'm going to give us how much minutes, boy? Alright. I'm going to give us 12 minutes to write out and think about how we will get this done, right? 12 minutes and 4 seconds. I know I spoil you all. But I spent all that time dragging my stopwatch on this page. I mean, you want to see the rules for the leap year? Is that good? Hold on there.